Alright, so this is the last problem from the analog and digital practice worksheet. We'll go over it if I can get my pen to work. So, what are some of the values we need to calculate? So, we need to find the amplitude. We'll need to find the period. Once we find the period, we can use that information to find the frequency, and then time high, time low, and the duty cycle. Alright, so let's get our given information taken care of. From here, we know the x value, horizontal, is going to be 1 millisecond per division, and the y value is going to be 5 volts per division. And we'll pick a place to start. You don't have to start down on, so I'll start here just to be different this time. So that's my start. So this signal, I go down, then across, then up, and across. And you notice that once I get here, I would start to go down again. So that's why I know that this is going to be my period. Right here, that's going to be my amplitude. And if I look, my frequency is related to my period. And then if I break this down from here, that's my time high. And then in between, when it's down at this lowest value, that would be my time low. So I have everything marked up and ready for me to go. Alright. So let's quickly get this done. So let's look at how many boxes tall is this. Right? So if I put this over here, it's 1, it's 2. So 2 divisions. Each division is 5 volts per division. 5 volts per division. Multiply that out, and I get an amplitude of 10 volts. The period. To do one complete cycle, there's one box, it's 2 boxes, so again it's going to be 2 divisions, but in the horizontal direction it's 1 millisecond per division. So that's going to multiply to 2 milliseconds. Frequency is going to be 1 over this period, but I need to convert it from milliseconds to regular seconds. And when I do that, I should get 500 hertz. 1 divided by 0.002. The amount of time high is 1 box, and also the amount of time low happens to be 1 box. So I can quickly get to that because they'll both actually be the same calculation. So it's 1 division the 2 milliseconds. Wrong. Let's try that again. It'd be 1 millisecond per division. So when I multiply that out, I get 1 millisecond. The work is the same here, so I'll just quickly rewrite that. And yes, our 1 millisecond for the time low and the 1 millisecond for the time high gets me back to my 2 milliseconds total. So the duty cycle is going to be the 1 millisecond for time high over the 2 milliseconds, and then convert that to percentage, and you should get a 50-50. Right? It's 50% of the time, or half the time it's at the highest, and half the time it's at the lowest. So this is number 4,